storing the metadata in a database, and that was typically a Postgres database, which has some advantages over MySQL, I think. And the structure of the database was very simple. It consisted of a single table, and that table had just 3 columns. As you can see here, it had, of course, an ID column, a timestamp column, and then a contents column. And you see this. I think nobody of you will be able to see what this is. When you don't know it, it doesn't matter. This is a byte array. This is a format quite. I think it's only used in Postgres database, but you can decode it with any normal programming language and get the real contents. This approach has some pros and some cons. Amongst the pros is that you have a very fast access to that metadata, as Postgres database is always said to be very fast, maybe not as fast as an Oracle database, but for our purposes, it's very good. But as you are not able as a human to read this, in the future, maybe in 10 years, in 100 years, or in 1,000 years, you may see something like this. You might have an idea then what this is, but maybe you won't have any more the tools to read that kind of data. And this is clearly what is a con of this approach. And this, amongst other things, was the reason because modern OCFL was introduced. The first discussions took place in Oxford in fall in 2017. When I joined that discussions, by the time I didn't see clearly the necessity to change that. But when finally OCFL was published I think in 2020 or so, I clearly saw that that was a great improvement. And the basic idea, you all know this wonderful picture of Patrick Hoekstenbach, is when all the world is melting down and everything is sinking in the mud, and you don't have any computers, any software, especially you don't have any Fedora anymore, your data will survive. Well, when anything is gone, the data will disappear as well, but the idea is you can restore the data without Fedora, without a specific repository. Then let's have a look. Like we saw this yesterday before. This is a very simple OCFL object on the file system, consisting of exactly 11 directories, subdirectories, and some files. You have that content in a version. You do have the JSON files describing that content, and the hash files protecting your data from being involuntarily overwritten and without being noticed by you. But here comes the thing where I would say size matters. When I'm executing the ls command on all these files, I get a total of 24 kilobytes. You see some of these files are very small, especially that one stating that it's an OCFL 1.1 info repository. The JSON files are quite small. even because there's no content in it, the Fedora container there, which has 0 bytes. Now I want to do some math with you. Not very difficult, not as difficult as this, but some math we should do. When I'm adding all these, the size of these 11 elements, I'm getting at the end, I did it for you already, I'm getting 19,276 bytes, which are slightly less than 18 kilobytes. But as I said before, executing the ls command, I had 24 kilobytes. Well, at the moment, that doesn't matter to me, a little bit more. This depends on the structure of the file system or whatever. But when I'm executing the disk usage command, then I have surprisingly 44 kilobytes. Why that? And the answer is again obvious. Any modern, or virtually any modern file system is organized in blocks, and typically a block covers 4 kilobytes, so that any file, any directory, even if it's empty, needs at least one block. And so we do here, and 11 times 4 is 44. So we do have here some waste of disk space, I would say. And the situation on our specific storage system, which is a network file system, is even worse. When I'm executing the disk usage command there, I'm getting 355 kilobytes. And still the truth is, I don't have a clear idea why is that. Our storage experts told me that it might be that because we have some duplication of data, because there is some backup space reserved, all that could affect the disk usage command. So not the real size on the disk is shown to me, but what is to be expected to be necessary for all your backups and all the stuff. But they weren't quite sure about that. So, but anyway, I see, well, that's not very nice. Well, when I have, in theory, only 18 kilobytes, and here on my disk I have 355. Yeah. But you could ask me now, does size really matter? Because you could say this is very little space. For example, because when you're storing your data, in reality, you're storing not empty objects. You're storing PDF files with articles or books, which might be some 10 megabytes of size. You might be storing some very big master TIFF files with 300 or more megabytes of size. And when you have that little overhead for one object, it won't hurt you. I would say, yeah, that might be true, but I have a counterexample. And this is the Chinese collection Schöner. In 18th century ancient China, there was an effort to publish a very big encyclopedia. I don't have really a good idea what is in there. But I find it fascinating that it's the same time as the European Encyclopedia of D'Alembert and Diderot in France was published. That's about the same time. The Chinese had the same idea to collect all the wisdom of their time in that Siku Kanchu collection. There's a nice Wikipedia article on that if you want to read it. And in 20th century, people in China noticed that this was ancient knowledge. We want to expand it, and it came up a collection named Shushu, which enhanced that Shikokanshu collection a little bit. And some years ago, we bought the digitized form of that collection and stored it in our Fedora 4 repository. And this is the way it looks like. You can't read it, I think, or maybe some of you are able to read it. But what you can notice here is that this is a quite poor scan. It's not color, it's not grayscale, but it's just simply black and white. And you have here some mostly TIFF, but even bitmap files, which are very small. Some up to 40 kilobytes, some 10 kilobytes, but there are even TIFF files with around 4 kilobytes. Well, very, very, very small images. And when your content is, is that small, then I would say the overhead of the OCFL files really do matter. To demonstrate you this, let's do some more math. In our current Fedora 4 repository, this collection needs about 200 gigabyte of disk space and database space. Well, mostly it's disk space, but a little bit data space as well. And it consists of a little bit more than 5,000 books with 2 million pages, I would say. When you do some math in your head, you can see these books can be very big. And indeed, there are some very small books with just 10 pages or so. But there also, the largest book has, I think, 40,000 pages. And all TIFF files, mostly TIFF files, I would say, are very, very small. And we don't want to have our content in a Fedora 4 repository any longer, but we would like to migrate this and various other repositories to 6 and, of course, to Fedora 7. And I computed a little bit, and I saw, well, we would need around 30 million files in our OCFL system. And we would waste, I really would say I would waste more than 1 terabyte of disk space. When I'm telling this to our storage responsibles, they didn't like the idea. Well, for one repository, it wouldn't. That would be easy, but we do have various repositories of that size and that structure, and it's very hard to see why we would use 5 times the space we used before. And apart from this, the organization of the disk could be a problem. You might know that on a Linux system, nearly all file systems are organized by so-called inodes. This is necessary to address the files on the disk. And you need for every file at least one inode, sometimes more. And it can happen when you don't configure your disks appropriately before you set it up, that you have enough disk space still, but you can't store anything any longer because you don't have any more inodes. Then you have to restructure your disks. And that's not an operation you want to do regularly. So what now? I have a feeling that many of you don't use anymore any local file storage system, but are using S3. And that's our plan as well. But of course, we won't use it. Won't do that with Amazon. The reason is, I would say, we are in, especially in Europe, especially in Germany, we're a little bit concerned about data security, data protection, and we don't want the highest and mightiest president of the United States telling to his friend Jeff to have a look into that data, what it is. That's maybe this is some paranoia we do have in Germany, but our tendency is clear. We do not want to store data in the cloud, but we do want to store data in our own data centers, specifically in Berlin State Library. We do have 3 data centers, and 2 of them, the data are replicated, and then we have a backup system. That might have some disadvantages as well, but we do not feel comfortable to store data in the cloud. So we're building up our own S3 infrastructure, and our tests are quite encouraging, would I say. Unfortunately, I didn't migrate all the data up to now. We're still facing some tests and some setups, and we're fighting with some ideas. Shall we just make a full migration, or is it easier just to migrate a part of the repository and replay then all the TIFF files or so. But as we could see, that object I mentioned earlier, needing in theory 13 kilobytes and more than 300 on the network file system, in our S3 storage, this object covers only 10 kilobytes. Oh, and I can explain that to myself only by that as far as I know, in an S3 storage, there are no real directories or so, but it's just an object storage. And so we don't have that loss of disk space and not that overhead. For me, it's quite amazing. I must admit, because I always thought that S3 is very good for very big files. We don't have at this point. But anyway, we will see what the future is really telling us. And that's I'm on the end. Well, until yesterday, I didn't know anything about what Neil Jeffries told about the packages which shall be introduced in OCFL 2. That could be an alternative. Yeah, that sounds good. But I will see how this works. But I would like to hear what you think. What your experiences are. Did you notice this kind of waste of disk space as well when you're using OCFL? And if so, how do you deal with that situation? Or doesn't disk space matter to you in no way? Well, yeah. And I would be glad to share my further experience with you when I finish that migration and I have a more clear picture of how much data disk space really was used then. You can contact me by email or on the Slack channel or whatever you like. Yeah, thank you.
That's great. Thanks, Oliver. Were there any questions or thoughts on kind of Oliver's situation or where where he's at? Yeah, Dorn.
Yeah, hi, can you hear me?
Yeah, yeah,
Yeah. Interesting presentation. Thank you. I'm with U.S. National Library of Medicine, and we experienced a lot of similar things to what you experienced. We also have hybrid architecture, um, and intentionally went to both cloud and on-prem. But yeah, I think even in our case, we're storing primarily the links in our Fedora repository, not even the binaries. And so it's probably even a leaner example than
Us-
yours, right? We're just storing information on where things live. And so
so
we
you do have the external content.
correct. Yeah. Coming
Yeah, yeah, I
from
see. Yeah,
correct. Coming from Fedora 3. And so we have something like 6 million pages and ended up with, I think, maybe 120 million OCFL files,
yeah,
as you described. And in process also, we're migrating this to partially to AWS. And so lots of problems in running out of inodes. And I think we experimented in both S3 and EFS in the cloud just to improve performance and moving data around.
I
So
see.
it'd be interesting to go into more detail offline, but certainly very heavy usage of many small files has to be managed carefully. I don't know if Calvin was our engineer who was working on this. Do you have any kind of summary thoughts, Calvin, on our experience with this? Not to put you on the spot.
Yeah, thanks, Ryan. Yeah, so I guess during our migration, we found that S3 transfer rate was kind of slow for the
Yeah,
amount of files that we have. So we opted to um, store our OCFL in the EFS. We find that's a better solution
yeah.
in terms of definitely in terms of the database indexing.
Yeah, that sounds interesting. In our case, because we do not use Amazon, of course we do have a local hardware solution for S3. So this will be very interesting if we have that kind of slowing down the ingest process. Yeah.
Yeah, yeah. If you have on-prem with high inodes, yeah, that can definitely be better for OCFL. Just thanks.
Awesome. Sorry, I wasn't sure if I cut you off there, Calvin.
Oh, no, you good? Thanks.
No problem. Any other questions or comments? No. All right. Well, thank you, Oliver. Hopefully,
Yeah,
we
thank
can help
you.
you sort that math soon.
I will see, but it's an ongoing discussion with us.
Absolutely.
So there are so many stakeholders from the storage, from the security, and anything else. But that's very interesting to see, and for me, especially, it's very interesting to see how that packages will work in OCFL too.
Yes, yeah. And I'll just put a pitch in too right now. This is perfect timing for the OCFL Java implementers group. So obviously Fedora, Dan and I participate in that working group. And I
Okay.
have just a quick, we meet monthly. Just let me get the information on this here. I'll show this really quickly. So the OCFL Java Implementers Group is a group of invested kind of individuals who are using the OCFL Java library in their institutions, not all with Fedora either, right? There's some that have plain OCFL Java. But we meet on the second Thursday of every month at 10 a.m. Eastern, and I can share the link to the wiki there. The invitation to come to the meetings is open to anybody, but we are actually in the process of kind of establishing and deciding maintenance and upkeep of the library, since the original author, Peter Winkles, has moved out of this industry. He works in another field now. But how to maintenance and upkeep that library, and then our attention, once the spec is written, will kind of turn to what pieces of version 2 or what features of version 2 OCFL Java will adopt, because not all of the features need to be adopted by all of the implementations. But I do think that package per version is something that the Fedora community specifically is interested in. So how we can incorporate those changes and what that means for our use at Fedora and for the rest of the implementers, what that means for the use of the library going forward. So I'll share the link to the wiki that has all the meeting information in it if people are interested. So